So with this, I would like to start the course, and this what we would be doing today would be, first we'll try to understand a little brief about the cloud and what the cloud models are there. And then we would also try touch base upon the Amazon. I would like to cover a case study, though it might be a little fictionary, but yeah, how the Amazon would be perfectly suitable in that. I would try to portray the picture there. Let's start with the cloud. But before I start the cloud, how many of you have used the cloud before? Okay, so some people may not have used the cloud, and I would like to contradict that, saying that, okay, you might be wrong. You are using cloud, and how? That's what one of the prime focus for us today. And as we say that the people now, everybody wants to go to cloud. So they say that all answers of these are the cloud now. So people would like to go to the cloud only. Now, going further, I'd like to quote a few things before I introduce you with the cloud computing. What is the cloud can do for you? Let's try to understand what the bigwigs of the computer industry, the cloud industry are saying about the cloud. So one is from the Mark Benioff. He's the CEO of Salesforce.com. And what he says is, the cloud service companies of all sizes, the cloud is for everyone. The cloud is a democracy. And he's the one of the first who were the first to reach the $1 billion cloud computing environment. So the Salesforce was the first company who reached the $1 billion for the cloud computing. And he's right, the cloud is for everyone. But does that mean that everything is cloud? We need to think on that. Does that mean that everybody is doing cloud? So what Mark Anderson says is, every kid coming out of Harvard, every kid coming out of school now think he can be the next Mark Zuckerberg. And I know everybody, every startup wants to compete with the Facebook, Twitter only. So their last goal is, would say, I would be like a WhatsApp, or I would be like a Facebook, or I would be like a Twitter, right? So if you have some idea has the value, idea has the money. Now you want to say, oh, I have a great idea, I can be next Zuckerberg. And my dear friends, to tell you, this can be true. This can be true with the cloud computing. See what Zuckerberg did, and now what you can do is, you have the power of better cloud. I won't say that Zuckerberg did not have the power of the cloud, but you have the better cloud available, much mature, which would help you to achieve your goal. So cloud is definitely a go-to thing for most of the people. And that's what they show, that the growth rate of the cloud, it's growing phenomenally. This is from the one of the infographic I received, and I'm just making based on that. This is how the cloud is growing, and the major market is AWS, infrastructure as a service. Now, what are those models? I would definitely come in a while. I would explain that also. But this is how the cloud is growing, the total growth of cloud, and you can see how the growth is. And to tell you frankly, this would be almost more than around 250 billions around by the 2070. That's what they expect. So that's what the growth of the cloud is. And then that's the different numbers coming out, and then so you can see this is by the growth of cloud. Gartner has some views, the Forrester would have some views. But to tell you, everybody does agree on one way, that there is no limit now, or there is no cloud limit for the cloud computing revenue. It's growing beyond the imagination. I would say it's a 11th, 15th, 13th cloud, something like that. It's growing more and more. That's the growth of the cloud people are thinking. And have you missed the bus of the cloud? Or is it the right time to catch the cloud? But before all you decide that, don't you need to know what is real cloud? What does cloud mean? And for that, I would like to quote from our own Mr. Larry Ellison. The Larry Ellison is we all know who he is. Only thing is, Oracle is one of the late adopters of the cloud computing. They did not believe in the cloud before. The reason was, if you read this, what he says, and it's a kind of a right. He says, they don't call it internet anymore. They call it cloud computing. I'm no longer resisting the name. Call it what you want. See, he has made a very famous statement about the cloud computing, and he was literally hesitant. I would say Oracle was very late adopter of the cloud computing. But then they realize that cloud is a go-to world, and then they come out with some of the innovative offering for the cloud, and then they are offering the Hexaware and then Hexabase, Hexadatabase, and everything they are offering over there. But that's the thing. You need to understand. Otherwise, what will happen? Everyone say, and that's, I have a cloud application. Do you know? I have a cloud application. I have made a cloud application. Now, you would believe him unless you can ask him, are you sure you are a cloud? I know what is cloud. And that's the objective for me today. At least when you go out, you know what is cloud, or you can ask the people, what does cloud mean? Now, that's what, again, Larry Page is something. Computing is a kind of a mess. Your computer doesn't know where you are. It doesn't know where you're doing. It doesn't know what you know. And at the same time, Google wants to know everything. If you try to compare, Google wants to know everything. They want to know who you are. They want to know what you are doing. They want to know where you are. And they would keep all the kind of a data available for them. So next time, a very generic application, everybody knows that whenever I am going to office at 9 a.m., my Google app, Android app would know that, okay, I'm going out every day 9 a.m. Sometimes it would give me some reminders also saying that, okay, this is the time to go to office, or this is the time you should do this something. They know, they are tracking me. How? They have the real power of that. They are on the cloud. They are providing the cloud. So, with all these buzzwords, I still continue a little bit on the buzz saying, what is cloud computing? Now, as I mentioned before, everybody would have their own kind of a definition on the cloud. So it's more like a few blind men, an elephant. The people who is touching its tail would say it's like a rope. People who are touching its the ear would say it's like a fan. Somebody touching its trunk would say it's like a snake. Everybody would have their own definition. And who is not touched the elephant, they would always say something, it's like a lion, or it's something like elephant, or even they have a dog, they say it's an elephant. Because they don't know the cloud computing. Every Tom, Dick and Harry wants to say, I am on cloud, I have a cloud app. And that's where the real understanding comes in a picture. So to give you some definition, cloud computing is a form of standardized IT-based capability such as internet-based services, software or IT infrastructure offered by a service provider that is accessible via internet protocols from any computer, is always available, scales automatically to adjust demand, is either pay per use, advertising based, has web based or programmatic based control interfaces. That's not an easy definition to understand. Do you think it's an easy definition to understand? No, it is not. So what? Then what's the next definition? We follow the standard definition given by the National Institute of Standard and Technology. That's a standard company who would be defining the various, they are working on the different standards, and they have defined cloud computing as a model for enabling convenient on-demand network access to a shared pool of configurable computing resources that can be rapidly provisioned and released with minimal management effort or service provider interaction. This cloud model promotes availability and is composed of 5 essential characteristics, 3 service models and 4 deployment models. I define cloud computing. I'm using the word very carefully. Remember, I define any business service. Any business service which is available over internet, which is available on demand, so whenever you need it's available, which is scalable in so when you want it can scale up, which uses the resources optimally, that's the fourth one, and which charges you on a pay-as-you-go model. Any business service which is available over internet, on demand, scalable, which uses the resources optimally, and charges you on a pay-as-you-go model, is called cloud computing. Does it make little more sense? Does it clear some doubts? Now what do I mean by the business service? The business service, anything which you are offering on a service model. For example, you want to offer email as a service. You want to offer CRM as a service. You want to offer hard disk as a, or the virtual machine as a service, or infrastructure as a service. That could be your virtual machines, memory, CPU, something like that. You want to offer the collaboration as a service. You want to offer messaging as a service. Something as a business service you are offering which follows these 5 key things is called a cloud computing. Does it make more sense now? Little easier to understand? Any business service which follows these 5 attributes. Now, what are those 5 attributes? And why did I use those 5 attributes? Remember, I used the word 5 essential characteristics. These are the 5 attributes defined by the NIST. So let's try to understand those 5 attributes first in little detail, and then we can think of how we can use it. So first let's understand those 5 attributes. First attribute, broad network access. Something which is available over internet to everyone. You can access over internet or you can access over intranet. Now why do I use the word intranet? It can be for your organization only. It can be for your everyone also. So it can be on over internet or it can be over intranet also, right? So this is what called the broad network access. You can access. It should not be like a client server kind of a thing or desktop based application. It should be available to everyone. Now you'd say the all applications are available on internet. Most of the applications is today, right? So they cleared the first criteria of the cloud computing. Second one, rapid elasticity. So let's try to understand one use case. For example, Osama bin Laden was killed a few years ago, right? Now when Osama was killed, it was a complete top secret mission for the USA. And after he was killed, Obama came and announced, so I just say Obama now, he came and announced that, okay, we have killed Osama. That's great. But what has that caused? That has flooded the CNN website. That has flooded CNN website so much that they might not have expected. That much load has come because everybody wanted to check whether it's a truth news, what is happening across the world. People are coming to the CNN.com to know the news. How did it happen? Who did? What happened? Everything was there on the CNN.com. And not only Americans. You can go to any globe. They were trying to check on the CNN. Now, how would that be possible? CNN, generally, if you see CNN.com would have generally a traffic of, you can say, 10 million or something like that. This is just a fictitious number given by me. But just for a reference, if CNN is having a traffic around 10 million users. Now, due to this, it may happen that the traffic has increased to the 1 billion users. Because whole world is at the CNN.com. They want to know this. Now, how could you do this? Would CNN be able to cope up that? There would be 2 ways for CNN. If CNN is having their own infrastructure, in 2000 or 1990 somewhere, they might have thought that something miracle would happen, or in 2005 something, and we might go the magical figure of 1 billion users. So currently they have for example, 1000 servers which can serve 10 million users, just in reference. Again, all are some fictitious number, but just for the understanding. Now, once you have 1000 servers which can serve 10 million, now they might think, okay, someday we may go to 1 billion also, so we should be able to cope up that usage. So let's go and purchase 9,000 more. So we should have at least 10,000 servers. So whenever our load increases, we should be able to cope up that. Now they might have done this in 2002, 3, 4, some years. This thing happened somewhere in 2011. Again, 11, 12, something like that. By the time of in 6 to 7 years, this hardware might have been already obsolete. They would have to keep on upgrading each and every infrastructure, which may not work for them. How would they work on this? What if there is some infrastructure available when they require it's available on demand to them? Means, if you are going to the market and you are trying to buy a server, how would you buy a server normally? You would go to the Chroma or Vijay Sales, or if you're in the USA, you might go to the Best Buy or Circuit City, or you would go to the Amazon.com or Amazon.in, Flipkart, somewhere. You would try to find on that. Right? You would do the research a lot. And if you are part of some organization, they would send to their vendors, they said raise a PO, and then vendor would accept the PO and then they would ship this device to you. Now this may take how much days? 1 day, 10 days, 3 weeks, sometimes more than 4 weeks. I have seen cases where it would take 4 weeks. Now, if they know that I have to grow up from 10 million to 1 billion, and even if they have to wait 1 day, that is a complete useless for them, because this is the day, only 1 day's magic. If you work today, it works. If you don't have the capability, you fail. The whole world would be on you saying, you fail, you did not deliver, and that would be done. So you need some infrastructure which should be available on demand. Whenever you require, it is available to you. That's on demand. And again, it should be automated. So whenever you need, you don't need to keep on going and requesting. Or even if you request, it should be available to you, or automated, it should be way work for you. That's an on-demand way. 5 minutes, 10 minutes, that's the max it should take. If it's going to take it 1 day, it's not useful for me. And it should be able to scale up. It should provide elasticity. So 10 million to 1 million, it should be able to scale up more. If it can't, you can't help it. So it should have a broad network access, on-demand self-service, and rapid elasticity. So from 10 million to 1 billion metric is, when you request, the infrastructure should be available, and that infrastructure should be able to adjust to 1 billion use case also, or 1 billion users. That adjusting to 1 billion users is elasticity, and providing infrastructure as per requirement is your on-demand service. Now, you get this infrastructure in just 10 minutes. You used it for 1 day. So you used around 9,000 more servers for 1 day. Would you pay for 365 days or 1 day? Wouldn't you love that I pay only for 1 day for those 9,000 servers? That's what called the measured service or pay-as-you-go model. You pay for the only service which you are using. Only service which you are going to use, you would pay for that only. That's called the measured service or pay-as-you-go model. So for those 9,000 servers, you would pay only for 24 hours, not more than that. Broad network access, on-demand self-service, rapid elasticity, and measured service. We talk about the 4 key attributes. So to giving an example, there are 3 automobile companies. We take the 3 names, Maruti, and we can take the Honda. These are the 3 automobiles company, or the one of the leading automobiles company of the India. Now, they all want to make their CRM kind of a system. So they approached one of the big house. You can think of it. It can be Infosys, Wipro, TCS, could be HCL, anyone. They approach a company saying that, let's take an example for Infosys. So they approach them saying that, okay, I want to make a CRM. So Maruti says, you make a CRM for me. Hyundai also wants a CRM from Infosys. Honda also wants a CRM from the Infosys. Now the case would be, Maruti says, I need something custom because I have a 20 models. In my CRM, I would need some of the customer information. I need their first name, last name. I also need their contact information, their buying pattern, all that I need information. Hyundai says, no, I need very simple. Just make a normal CRM which would be there okay for me to use as of now. I don't want to spend a huge amount. Honda says, no, I want a complete jazzy application, a different GUI, and I would also have something like where I would get the buying patterns. I would need some analytics also. I'm ready to pay as much you as we want, but give me a perfect CRM system and it can go beyond that. Okay. Now, the company who is going to develop, they know that, okay, I'm going to develop for all three. It's at the end the CRM system. Why don't I create a single CRM system which can cater to all three? But doesn't the three have the separate requirements? Yeah, but the company says, I can manage. I can write down a certain rules saying that if the person is coming from Honda, he would see different kind of a GUI. He would have a different kind of a rules. I can handle that in my CRM application only. I don't need to make 3 CRMs. I would make just 1 CRM and giving to them. Hyundai would have a very simple CRM. Maruti would have a customized CRM. Honda would have a very jazzy CRM. I would give them all from single CRM. I would be hosting for them. Cool, that's possible. And whoever the users of the Maruti, the sales representatives or the company employees, they would be using the same CRM. They would never know. So I am using the CRM provided by Infi, Wipro, whatever, but they would never know that same CRM is being used by the Hyundai or Honda, because they might have a different GUI, they might have a different things. What is this all about? Why this case? Here, Maruti, Hyundai and Honda are called the tenants of the CRM application. Now, what is a tenant? Does it mean they are staying here? They are renting this place? Yes, kind of. They are renting this service. This Infi or whatever company would be, they would be charging based on the usage. They would be providing them over the internet with elasticity on a pay-as-you-go model on demand. Plus, it would be customized in a way, such a way that for Maruti and Hyundai and Honda, they would be using same system with the optimal resources. One system being customized for the different tenant differently. What is the tenant again? I'm not clear, right? What is a tenant? Tenant is nothing but a group of users for whom the application is customized. So here in this case, when you try to understand, Maruti would have thousands of employees. They would be the end user of the CRM. Honda would have 500 users. They would be the end users of the CRM. Hyundai would have around hundreds of users. They would be end users of the CRM. But Maruti, Hyundai and Honda, at the end, they are called the tenant. They are the group of the users. For them, the CRM is customized. So tenant is nothing but a group of users for whom a cloud application may be customized or whatever specific cloud working for them, which would be following the above 4 attributes. But Tarun, you did not mention about tenancy here. You are talking about the resource pooling. Where does the multi-tenancy come in a picture? You achieve resource pooling. What is resource pooling? Resource pooling means optimally using your resources. For example, you have a 100 GB RAM machine with 1000 GB hard disk. Now, if only one user is using this app, then it's useless, right? Because you are wasting all the resources. 100 GB, 1000 GB RAM, 100 GB hard disk, you are wasting all the resources. How would it work? Why don't you do such a way that the same machine you split across 10 people? Each user would get 10 GB RAM and 100 GB hard disk. Optimal resource utilization. How did you achieve? With resource pooling. With resource pooling, you can achieve optimal resource utilization. And why this multi-tenancy? Multi-tenancy helps you here achieve resource pooling. Or here you would be saying you are sharing this with the 10 different tenants. So each tenant would be accessing something, or some of the users of this tenant would be accessing this. So with multi-tenancy, you can achieve this resource pooling. Fifth attribute, resource pooling. Everybody clear? Any business service. Now let's try go with the any business service which offers broad network access or available over internet, elastic in nature, available on demand, optimally uses the resources, and provides a pay-as-you-go model is called cloud computing. So there is a question, is resource pooling across multiple machines possible? Yes, there would be possible in two ways. Like what would happen? If when I go to the cloud, or when you join the session, you would say, when you go to the AWS model, in infrastructure as a service model, you would have a, so I will come to that point later, but what is AWS? But you have a huge number of server farms. Now that server farm would have thousands and hundreds and thousands of servers. Each server would have a multiple machines running on that, virtual machines running of that. Now, if I am an end user, or I am a user of, or I am a tenant who is consuming this AWS, my one instance would be running on one machine, one instance might be running on second machine, one instance might be running on some other machines. For me, AWS service providers provides me on-demand self-service, a single view kind of a scenario, but I don't need to worry, I don't need to think where it is running and how it's running. It would be internally taking care of the resource pooling, providing me on-demand measured service with elastic on-demand. Right? Does it clear you? Answer your question, Dheeraj? So, cloud computing. Now, a few guys say that we don't know the cloud computing. I said, you are not right. Are you using Gmail? Are you using Facebook? Are you using Office 365? Are you using Dropbox or Box.net? Are you using GoToMeeting, WebEx, and so many options? They all are the examples of the cloud computing. Now I'm sure everybody would say that Gmail is since last 15 years. Then, but cloud I am hearing since last 6 years. Nobody said that cloud is 6 years. Cloud is since almost 20 years back. The cloud word has come since 20 years back, but it became more popular due to availability, more commoditization of the infrastructure, better understanding, better services, maturity of the infrastructure. That has made the cloud computing more possible and a buzzword across the industry. Now, one more time, if I want to explain the attributes with the concept of the Gmail. So I hope that would be the last nail in the coffin, I would say, which would clear your all doubts how the cloud would work for me. Gmail, when you go, you sign up as an end user and you get all the free Gmail service. That's fine. But at the same time, Gmail is also having a lot of other use also for small, large, extra large environments, or the small and medium and large enterprise also. The Gmail offers a ready to use service for that. For examples, I know at least even I myself is having a 4 to 5 the corporate IDs of the Gmails, various different IDs, which provides you that, okay, you don't set up your own infrastructure. Even our Edureka is also using the Gmail as a backend. How? They would go to the Google saying that I don't want to set up my own infrastructure. I want to use your infrastructure because you have ready application available, you have the infrastructure. Why should I invest on that? I don't want to reinvent the wheel. Okay, then how would I use it, they say. But remember, Edureka says, my email address should be something like tarun@edureka.co, rajiv@edureka.co, or om@edureka.co, something like that. It should have the email ID like that. Gmail says, I'm fine. You need something mail action servers and all that part. I'll take care of this. You just need to own the domain name. You give me some of the host file settings over there. You make those configurations. We are all set. We are all set to go ahead. Okay. Then how would this work? When you go with the Gmail, they would say, okay, I'll provide you a self-service where you can create as many as users you want to say. Today Tarun is with you. Next day there would more Tarun is coming up. Or there are more trainers coming with you. You can keep on adding more and more emails. When you don't want to them, you just remove their IDs. I would charge you user basis. So if you have 20 users, I would charge you for 20 users. If you have 5 users, I would charge you for 5 users. Pay as you go model. How many users you create, I would charge you based on that. Gmail is available over internet. So you're there. On demand, you create a user, I am available. You don't need to worry. You have 5 GB storage, 50 GB, 500 GB. I am there for you. I can be. Resource pooling or multi-tenancy? Obviously, you need the email ID like edureka.co. This is the email ID I'll provide. So what I'll do is, you give me you need to own the domain name. So you own the domain name as edureka.co. Okay, perfect. And you give some of the host name settings. Make that in your Google Mail account. Now you can create as many as IDs with name something like tarun@edureka.co, akansh@edureka.co, om@edureka.co. Whatever you want to create, you can create that. You would have those IDs available. Even our current tarun@edureka.co is running on Gmail. So that's what the Gmail. See, resource pooling with the multi-tenancy. You get the customization as your name, edureka.co as a name, as an email ID. If I told you at the first that I am mail me on tarun@edureka.co, can you ever imagine that actually you are sending a mail to Google or you are sending a mail to Gmail? You are not sending to edureka.co because edureka.co is a domain name. The mail facility or mail service is provided by the Google, which is mapped with the edureka.co. So Gmail provides you broad network access, rapid elasticity, measured service, pay as you go, and resource pooling. Clear everybody till now? How the cloud works? I hope this was the most important aspect. So I spent a huge time here, but I wanted to be very clear that what email can do for or what cloud can do for you. So now when you go out and you try to talk about the cloud computing, this is the question you can ask anyone. Are you providing broad network access? Are you providing rapid elasticity? Do you have the measured service? Are you on demand? Are you providing the resource pooling? All those questions you can ask, and then you can say, boss, you are not cloud computing. You are just bluffing to me. You need to be a cloud provider. This is how you be a cloud provider. Any business service, now very easy definition for you. Any business service which follows the 5 attributes defined by NIST is called cloud computing. Isn't it? Now anybody asks you definition of cloud computing, you can just close your eyes and say any business service which follows the 5 attributes of the defined by NIST is called the cloud computing. Now what are those 5 attributes? They are here. Now service models. See, this is the game of the service. We are offering some service to the end users. So based on that service, the cloud has 3 models. First one, we go with the infrastructure as a service model, where you offer an infrastructure to a user. It can be a virtual machine, virtual server, virtual desktop, network, something like that. Infrastructure as a service. You get infrastructure. You would have a full access of that infrastructure. Whatever you want to do there, you want to install something, you want to play with that, you can do that. And infrastructure, which is following the first 5 attributes, infrastructure as a service model. Now, in some of the cases, You may need the infrastructure, but you are not an infrastructure guy. You don't know how to scale up, how to manage everything. You say, it's okay, I get it, but I don't want to manage all this. Yeah, that's just the tiresome. What if there is a platform available which can do the management on behalf of you? Which would you need to focus. You are a developer, hardcore developer. You focus only on development aspect. All the scaling, infrastructure provisioning, scaling up, scaling down, load balancing, everything, backup would be taken by this platform. When such a platform is offered, that is called platform as a service model. In infrastructure, you get a raw infrastructure where you configure everything on your own. You plan for scaling up, you plan for the backup, you are responsible for that. In the past, you don't need to worry, you just focus on your application. Everything else is taken care by the platform as a service model. And if something is there, which even my mom can use this, she doesn't need to worry how to develop, how to code, everything. Then it's a software as a service model. A software, ready software available to you. Imagine Gmail. Does anyone need to learn a lot? No, you just sign up, you start sending mail, you start receiving mail. That's the Gmail for you. So very easy, Salesforce, a ready software available to you. You don't need to learn something. That's the example of the software as a service model. Now this is a fashion oriented industry. They need the buzzwords. And now people started coming out with a lot of buzzwords saying network as a service, management as a service, business platform as a service. So that's why the new term coined out, which was anything as a service. But NIST does not recognize this. This is more from the fashion-driven industry of the cloud computing. So they coined the word XSS. But generally speaking, the three core service models are SaaS, PaaS, and IaaS. Now for us, where do you deploy the cloud? That also makes a difference. If you are deploying cloud in the public, which is available over internet, that is called the public cloud. Anybody can access. Amazon, Microsoft, Google. Those are the famous example of that. Something which is available to you privately, which only you can access. That's called the private cloud. You means your organization. Something which is only for your organization. You don't want to share it to public. You want the secure data. That's a private cloud. Sometimes you want the combination of both. You want the secure as well as you want the public, both the parts. You call it a hybrid cloud, which is mix of both public and private. And sometimes you want a case where some like-minded people, like this days, Maruti, Hyundai and Honda comes together and say, let's make our own cloud, which only we three would be accessing. In that case, it is not public because it's not available to everyone. It's not a private because it's not available to one organization. It's not hybrid also. This is community where like-minded people come together and form a cloud is called community cloud. So, sorry, I took a little bit more time than anticipated, but I thought this was one of the core part when you want to understand the cloud. This is very important aspect. So I took little more than anticipated, and sorry for that. Now, let's try to understand what is the difference between cloud versus on-premise. Now, on-premise would be something your own data center where you control everything. There would be some more option would be like a hosted part, which is like you take a rental where you can decide which infrastructure you want. You would have a physical access. You can go, you can decide something, which kind of internet they should be, but that would be not your own data center. The biggest difference would be when you start moving to the cloud, you start losing control. Your own cloud or your own data center would give you the best of the control. You can design, you can put whatever you want to do there. When you go to the cloud, public cloud, you would have a less control. At the same time, you would have a less responsibility. All backup mechanism they would have, They would have all high availability scenarios. They would provide you best of the offerings. They would also have their own kind of a security mechanism if you can implement that. So it's a vice versa. You would have a more control if you have the good resources, good money, everything. Go for your own cloud or your on-premise scenario. If you don't have a huge amount and you don't want to invest or something there, or you trust the cloud provider because they have the right resources, right money, everything there, go for this cloud hosted model. And these are some of the famous examples of AWS, SaaS and PaaS. In the infrastructure, you would see Amazon, Azure, Google, Cloud Computing Engine, and there are so many over there. In PaaS model also, we have a Google App Engine, Cloud Foundry, and Cloudera, and APG, and a lot many are there. Well, in the SaaS model, you see a lot of Office 365 and the Outlook Online and the Google Docs and the Dropbox, and so many all examples are there for this also. Does cloud offer data security? Obviously. And I'll tell you the story, or rather let me park you for a while. When I go to the Amazon, I'll explain you this. So my friends, I bring the part of the cloud computing to end, but the webinar has not ended. We still have around 15-20 minutes to go. This is what the cloud computing is. I'll now take you to the journey of the Amazon Web Service. But before that, any questions? One question I saw about the security. Anything else? Are you all clear? Okay, cool. So let's understand the world's largest infrastructure as a service provider, which is having massive, 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 massive infrastructure. Now, why do I use so many times massive? Is it really so much massive? Or I'm just making some hype? Let's see that. Amazon Web Service is one of the most, I won't say one of the, is the leading infrastructure as a service provider. Now we all know what is Amazon.com. You also know that Amazon itself is having a seller business where you can sell your products over there. Amazon's own IT infrastructure business is known as the Amazon Web Service, which is world's largest infrastructure as a service provider, which is having massive infrastructure. And as I said, I won't use the massive, it's a massive infrastructure. But before that, it also having huge product portfolio, almost 40 plus products portfolio available there. And for that, it would have products for the virtual machines, virtual storage, virtual networking, virtual domain name service, load balancing, data warehousing, Hadoop, for mobiles, security, key management, archival, data syncing, search, email, you name those things, you would find it here. And I would say I just listed 50% of the products here. Amazon is having almost 35 plus products to offer. And why did I use massive so many times? In 2004, when Amazon.com was the largest service, internet retail, online retail service, they had almost 7 billion plus retail business. Total revenue was $7 billion. They were having 8,000 plus employees, and I'm sure they must be having around millions of users. Now to serve those millions of users, they must have some thousands of servers, right? Whatever the infrastructure they had in 2004 to serve this requirement, similar kind of infrastructure they are adding to Amazon Web Service data center every day. Every day they are adding infrastructure which is capable of serving entire 7 billion enterprise. Now you can imagine why I'm using this word massive, massive, massive. In the 2013 For Gartner survey, Gartner put always Amazon in the leader quadrant, but I would say in the 2014, in this leader quadrant, Microsoft was somewhere here. There were only two of service providers who were in the leader quadrants, and Amazon was somewhere here. As per 2013 records, what Gartner predicted that there were total 14 service providers. They did not count Google that time because Google was not in AWS. Total 13 infrastructure service provider. If we total the infrastructure used by their clients, and if we just consider the infrastructure used by Amazon's clients, the infrastructure used by Amazon's client is 5 times more than total of those 14 service providers infrastructure used. Now you can imagine why I use the word massive. 5 times. And it's a cricket flavor. Cricket World Cup is on. Everybody wants to go and see the World Cup. So let's try to learn a use case where Amazon can help you to achieve a really highly available disaster recovery performance application. So this is the story of 2010, February 24th. On February 24th, our own, the cricket's god, made the history. He hit ODI 100. Now that has broken a lots of records, and we all know it's been broken already a couple of times. But on that day, he did not broke only cricketing records. He broke something unique thing. He broke the Cricinfo's website. What? On that day, it crashed the Cricinfo's website. Now, what is so significant about that? Can you imagine the huge growth in that? What Cricinfo has to publicly acknowledge, generally, they have 5 million average users a day. That's the average users. On that day, they had 45 million views. 9 times. Now, how would they survive? Any application would crash, and I am sure it would crash. But if they were on cloud, then they could have survived. How? Let's try to understand the case. First, just for your reference, all this data is fictitious. So I don't know what Cricinfo is using at the backend, whether they are using Amazon, they are using Microsoft, or they are having their own data center. I'm just giving this for just your understanding purpose. So considering the case, Cricinfo started somewhere around 2000. Again, I may be wrong for the numbers, where they might have around 50,000 users. Around 50,000 users, right? By 2008 or 9, something we can say, they might have around 5 million users. And now by 2014, they might have around 30 million users or viewers. And since it's a World Cup, this would be the case. This is a generic case. Now when we want to show the actual usage, what would happen? The actual usage of the Cricinfo is shown by the red. So this is their rate line, shows how much they are being using this Cricinfo's usages. So this shows that Cricinfo, it's not that every day there is a match being played and everybody would be going there. Whenever there is a match, and popularly when there is an India match, it would have a more traffic. Again, since we are in India, we say that, but it may be true for Australia or New Zealand or Africa also. Or there is some World Cup, there would be more traffic over there. Otherwise, the traffic would be less. So if we just compare the actual usage, so in Cricinfo had procured an infrastructure in 2000 which can serve 50,000 users. in 2008 which can serve the 5 million users, and in 2014 which can serve the 13 million users. So this is the infrastructure which Cricinfo has procured. But their actual usage is very different. They have, by the time of the 2004-5, they have never crossed beyond 30,000. Hardly they reached 30,000 once. Otherwise they were way, so their most of the infrastructure was wasted. When they go to around 2004-5, their users started picking and they revamped their infrastructure. Only once they crossed the 5 million, just one time, you can say it's something in the 2007 or 2003 World Cup final, sometimes there might be a 4 million users, something, or 6 million users. Otherwise they were pretty less most of the time. So they are being still underutilized. Suddenly there is that match which has spiked up the usage, and it reached around 45 millions, which they could never meet. Even if they had a usage of the 30 millions, it would have faltered. How would it help them here? If they were having Amazon Web Service, Amazon would provide them infrastructure, on-demand, scalable, pay-as-you-go model, which is available on internet with the optimal resource utilization, which would help them to save a huge cost, available on demand. So whenever the demand increases, it could be able to meet up. Whenever the demand decreases, it could be able to save the cost also. So that's why it gives you elastic pay-as-you-go model to optimally use your resources as well as to save your resources as well as money also. And how would that they provide you? 3 foundation. Again, I'm just saying 3 services. Amazon has 40 and quite a few would be useful here. But just to go for 3 services, one of the services is called the Elastic Load Balancer, which would Amazon, for example, Cricinfo is having today 100 servers, each represent 25. So today they are having 100 servers, which is able to serve 3 million. Now suddenly load increases and then load reaches to 6 millions. So they add 100 more instance immediately. How would they add 100 more instance? For that, Amazon provides service called auto scaling, which can automatically spin up new servers for you. What about the load? Elastic load balancing provides you load distribution service, which would distribute your traffic to 200 servers instead of 100 servers. So your load would be distributed equally. It would not affect your servers. And how would that work? There is a service called CloudWatch, which would keep monitoring your resources, and whenever it finds something is wrong, it would inform auto scaling to spin up more instances. So these 3 services working together would give you the perfect case where you can spin up more instances as per your requirement. Even it's not spinning up. Spinning up means launching more. It can spin down also, so terminating instance when it is not required. So if I go back to the previous slide, whenever it's increasing, the yellow line would show you. I'll wait for the page to load. Yellow line would be whenever required, it will launch more instance. Whenever not required, it will terminate the instance and it would meet your demand. So it would work seamlessly for you with this 3 service. So Elastic Load Balancer, it receives the traffic, keep distributing with the, and it would be monitored by the CloudWatch. Whenever required, CloudWatch will notify auto scaling and it will launch more instances. Now, how do I know more? Yeah, so if you want to learn more about all these topics, we would cover all these aspects in detail. How do you achieve these services? We planned our curriculum where we would start designing Amazon Web Service from the core basic service to the scalable service. How can you design a scalable service with the Amazon using all these concepts? We would be teaching you in our course. And for that purpose, one of our core part or one of our key session would be architect design of a scalable services, where I would be teaching you how do you design this application which would be able to scale up. So to give you some hints of, Amazon is having a huge number of service portfolio. Now, how would that work? User request high available cloud.com. That would come to Amazon's Route 53 web service, which is a domain name service provider, which would try to map how highavailability.cloud would map to some IP 10.30.40.50, something like that. And that would send all your traffic to the load balancer. We just spoke about the Elastic Load Balancer. Elastic Load Balancer distributes traffic to your web servers, which are running on Amazon virtual machine known as EC2 instance. They would be doing processing, and whenever required, they would fetch the data from Amazon's own managed database called RDS. So Amazon provides a managed database service which offers MySQL, Oracle, MS SQL, PostgreSQL, and now Aurora. Aurora is Amazon's own database, which is considered as a 5 times faster than MySQL and much cheaper than the MySQL. A complete managed database, RDS, which would offer you this part. And you can also have a infrastructure available in a separate data centers of the Amazon. So even if one of the data center fails, the second data center would keep on working and keep serving your traffic. High availability. Even if your instance are failing, for that, Amazon provides the concept of regions and zones. Region is nothing but a geography where Amazon is having data center, and zone is where the data center is known as a zone. So you can have one server in US, one server in Singapore, one server in Sydney, one server in Europe. So all England visitors would visit the US server, Germany server. All American users would visit the US server. All Indians might hit upon the Singapore server. All Australia and New Zealand would hit upon the Sydney server. So even if you can configure with Amazon that if the Singapore server is down and if the Indian citizens or Indian viewers request, it may redirect them to now to Sydney. Even if one of the server is down, you don't need to worry. Amazon provides automated routing mechanism where even if the one zone is down, it would route traffic to the working servers. For the data, it has the managed database service. Now, what about these matches, the photos and all that? Amazon provides a static storage service where you can get all the photos and all the videos and everything much faster with the content delivery called CloudFront. This is more like a Akamai. S3 is more, you can think like it's a Google Drive where you can store anything static content over there. If you want to mail your users saying there is a competition going off the virtual cricket team and everything, Amazon provides a service called SES, Simple Email Service. You watch everything through the CloudWatch, how they are doing, performing. If you want to provide the caching of some of the data, because some data is frequently accessed, like he said, Sachin's profile is visited every day like 1,000 times. You cache that page using Elastic Cache, which is a caching service. You want to use something kind of a NoSQL database, Amazon has a NoSQL database. You want to provide a search facility, Amazon has a Solar Search. You want to provide a queuing service, Amazon provides a SQS. You want to provide some kind of a workflow, Amazon has a workflow service. You want to provide a mobile service, Amazon has a Cognito. You want to provide a security, Amazon has a multiple security services. You name the service, Amazon would have something for you. So Amazon would help you to achieve highly available website architecture, which would, even if one of the instance fails, it would keep serving your requirements. One more reference architect, this is from the Amazon website, so I'm just showing you. You can also make something like that, where you would have a auto scaling, load balancing, you would have a database from the CloudFront, which is a content delivery, like Akamai, you would have a S3. This is how Amazon designs. This is the reference architecture given by the Amazon. A real, highly available service. Now I'm sure everybody would have questions. Tarun, you spoke a lot of services. I'm not aware about all this. I'm not yet that. So I'm giving you a few references. These are the services which we used. Route 53 for the domain name. CloudFront is like Akamai for the content distribution. Simple Storage for the static storage. You can have Elastic Load Balancer for the load distribution. EC2 is your virtual machine where you can host your web servers. You can have a RDS as a managed database. You can use the auto scaling to scale up and scale down automatically. You can use the regions and zone concepts to achieve the high availability. You use the RDS. You can use the DynamoDB as a NoSQL database. So these are the components, and very few. I said I hardly took the name of the 15% of the components. There are more components available which you can use to make more highly available, more scalable, more secure application with the Amazon Web Services. And if you're really interested to know more about those services, we do conduct the course for that, where we would be introducing with the cloud computing with Amazon on day 1. We would be then introducing with the EC2, EBS, S3, Glaciers. We would be introducing with the scaling parts like auto scaling, CloudWatch, all that. We would be introducing with the IAM, that's a security part, and the relational database service. We would introduce with this lots of service others as there. And one of the key highlights, I would say, I'll ensure you design that perfectly. How do you design with the Amazon? Highly available, disaster recovery, with the best practice, cost optimized. How do you achieve that? And in the last day, I would give you tips. How do you prepare for the Amazon certification? So my friends, this is the session for the Amazon cloud computing and how can you achieve the high availability and disaster recovery with the Amazon Web Services. How to achieve the data security? See, cloud provider does offer you lots of security options. Amazon is not left behind, it's leading. And to tell you the truth, the ND Jesse, who is the VP of Amazon, in the recent Amazon event, he announced that there was a time people were worried to adopt cloud because they were worried about the security. And now, today, people are adopting cloud because they want to achieve the data security. Because Amazon, Microsoft, Google, they have the right resources. And resource means infrastructure, money, and manpower. Who can help you to design the best of the secure infrastructure which would ensure that your data would not be theft. If you don't plan it well, it can be a problem. If you design it well, Amazon has all sort of options available to secure infrastructure. Onus is on you. Did you design rightly or not? So now the clouds are becoming more and more mature and they are offering more and more secure environments also. Now question is, on which technology is Amazon deployed? See, Amazon is not deployed. Amazon is an infrastructure as a service provider which gives you virtual environments. For that, they use Zen open source hypervisor. Hypervisors are the softwares which help you to virtualize your environment to offer to multiple tenants. If you know, VMware is one of the example of that, popular example of hypervisor. Amazon uses Zen open source hypervisors. They have a huge kind of a data center. They virtualize the environment and they provide you self-service through which you can request the environment like a virtual machine something and they offer you that. I am done for the day. So we just lectured a little bit how our class would work. We would be having online classes where I would be teaching same way. The classes would be recorded and the video would be uploaded to our learning management system. All our PPTs also would be available to you in our learning management system. This is when after you join the class. We would also have you would have a 24/7 post-class support where if you have any doubts, questions, you can drop a mail to our support team and they would be able to answer you. It can be technical question also. If they can't answer, they would approach me or some other trainer and we would help you to answer. But generally, they would be your first point of contact. We would also give you some project work to finish so you can work on that and you can achieve something. And at the end, when you finish a project, we would also give you a certificate of your completion. I hope you all enjoyed the sessions and hopefully I might see you in the class also. So that's it from my side. If you don't have any other questions, we can end this webinar now. Thank you all for joining and I hope you all had a great time. Thanks and bye-bye to everyone.